So I want to talk about what I see as the future of software development in the AI era. Specifically, so much is changing and it's moving so fast, and you hear these people talking about, oh, develop AI is going to replace developers, or just all of this nonsense that all white collar jobs somehow are going to be replaced by AI. And I mean, you and I both know it's BS. And behind the scenes, Sam Altman, who I'm not a fan of, Jensen Huang, who I think is brilliant, and just like Sam Altman and the Anthropic dude and everybody else in the space, they're CEOs, they're selling their companies to investors. They want the excitement, they need the sizzle, they need that investment money. So they're going to say crazy stuff that excites people and, all like that. But meanwhile, where the rubber meets the road is where you and I live. And I want to get into some of that. So, and you might push back. You should push back. But Jake, they're laying off all these people and they're claiming that, oh, well, 95% of our code is, being written by AI now. Well, let's get into that. First piece is let's get the dose of reality going here. First, they're lying. Okay. The driver behind these layoffs, there's a couple of things, and none of them have anything to really do with AI. First thing is interest rates. Powell ran the Powell, yeah, Jerome Powell. He's driven interest rates through the roof, so it's very expensive for companies to go borrow money. And generally speaking, that's how companies hire people and invest in capital expenditure projects. They go borrow the money to go do stuff, and then they pay off with profits that they make, that they expect to make anyway. Next, the tax law. If you look back, a lot of these layoffs started back in 2023 when things got heated because the tax law changed. It used to be those capex expenditures, they could write everything off that year. So if they hire you in 2026, they can write off your entire salary in 2026. They don't have to depreciate it out over, I don't know how many years. I'm not a tax person, but I just know that that was one of the things behind it. Between the interest rates and the change of the tax law, they made us, the software developers, really expensive. The next piece is, if you dig into what's going on, while the CEO's up on stage saying, oh yeah, AI is doing all this great stuff and we're laying off all these useless programmers, you dig deeper and you find out that they laid off 10,000 people in the US and they're hiring 14,000 offshore, India, China, somewhere else, not here. And so, they're doing arbitrage because, hey, a dollar buys a lot of rupees, just economics. So none of that has anything to do with AI. AI provides the nice excuse and it sounds better. Into this and into what I'm looking at is AI is going to make building solutions cheaper. Now, I realize you're like, wait, just a second, Jake, you're saying AI has nothing to do with this. Well, if you're using it, you can see that, okay, a lot of scaffolding, there's a lot of stuff that it can help me do. And what I can tell you is I'm learning it. I'm actively in the process of catching up to everybody else. And what I'm seeing is, as I learn to use it, there's a lot of spots in my job, both as a software developer and as a site reliability engineer and as a DevOps engineer, that I'm like, okay, Copilot can help me do these things and make me more productive. And by me being more productive, that means building solutions gets cheaper. And if you took 10 of me or 10 of you, and each one of you is 10 times more expensive, all of a sudden those solutions become really cheap. So, first piece to that is AI is going to make skilled software developers even more productive. One of the things, through my career, I've heard this stuff about, there's some developers are like 100 times more productive than others. I don't think it's 100. There's a few who I see maybe 2 or 3 times, but I think if you're really good and you figure out how to use prompts and you build yourself a really good workflow, maybe you could be 10 or 100 times more productive than people who don't use the tools. But AI is just a tool. It's like with that, because you get really skilled with it, suddenly it's cheaper to build stuff with the assistant. And so that's going to increase the demand, because if all of a sudden a solution that used to cost $10 million to build suddenly costs $1 million, hell yeah. Companies are going to invest in that all day long. And the thing is, we're nowhere close to solving all of the problems that algorithmic, just deterministic systems, traditional IT has not solved all the problems yet. And there's a big space there where AI is not really helpful in these problems. I mean, I'm sorry, your basic, you know, CRM solution doesn't need AI. A form that lets somebody put in customer information, AI doesn't help. Sorry. Being able to look up and send email to a bunch of customers that happen to live in Spokane, Washington, who bought a snowblower in October of whenever. You don't need AI for that. You just need code. That's all. So, but the AI can help you write that code more quickly and test it and help you put together the pipeline that gets it deployed. And so something that used to take, say, 3 months to build suddenly takes a month. Maybe I'm overestimating, but you get the idea. So next, just kind of prognosticating here. I think 2026 is going to be nuts, because first thing is we changed the tax law so that, love him or hate him, the big beautiful bill passed, and the tax law for now is going to let the companies write off all of their investments right away, so they don't have to depreciate anymore. Next piece is what he did with H-1Bs. No animosity, in my opinion, towards my Indian brothers. They're no different than me. They're just mercenaries looking to earn a paycheck. And hey, it's a good paycheck, man. But change to the law means that companies have a choice, either to hire people already in the United States legally, God, or they're going to accelerate offshoring. Both are going to be problematic. It's a lie that the talent is not already here in the United States. When they say that, oh, there's not enough developers in the US, it's an incomplete sentence. What they mean to say is there's not enough developers in the US who will work at the rate we want to pay. And, well, now they don't have, the economics have been changed. So we'll see how that works out. Other piece that I don't have a bullet point for is interest rates are starting to come down. I don't know how far they'll go down or if they might go back up. Who knows? But as the interest rates go down, that also makes it cheaper to develop solutions. So you have the change of the tax law and lower interest rates. Hey, that's good news, right? Right now, the expectations, like I said, these guys, Anthropic CEO, Sam Altman, God love him, all of them are out there just playing cheerleader, hyping up AI. And the solutions are the projects are in flight. And it sounds like a lot of them are failing. I realize the MIT study thing has a lot of problems. But I spent 30 years as a consultant, doing that stuff. And I kind of know how these projects play out. And while the MIT study is problematic and the methodology is terrible, I don't think it's an entire lie. I think you should take it with a big grain of salt, but I don't think you're going to see, just capability maturity model says most projects are going to be challenged anyway, meaning either they go over budget, they blow their timeline, and or they don't deliver all of the functionality they promised. Well, that sounds, that's going on with just regular IT stuff that we've been doing for what, 50 years? And you think you're somehow going to be more successful out of the gate with AI, something that is even more complex? I mean, you sit there and you listen to the AI research and like, I forget the guy's name. He's like, it's inscrutable code. Yeah, we know how the neural networks and all like that. We know how to write that code, but how they're deciding to come up with the answer they produce, yeah, it's statistics. It's magic. So these projects are going to be at a minimum challenged, if not outright failures, meaning the company just basically says we're going to flush the budget that we've already spent and we're just going to abandon it. You'll see, a mixture of that. So as the expectations come down to reality, that's actually great news for us because that means the projects that are going to get budgeted in 2026, 2027, and so on are going to be more realistic. And the expectations, because organizations will have burned their hands on the hype, they'll be more respectful of what they're trying to do. The magic will be out and it's going to be hard work, which, okay, that's why I'm here. I like that. So, all right, enough of that crap. Let's get into it. I kind of see solution development splitting into three paths. You have the traditional software engineering, solution development stuff that I've done all my career, and I expect you've probably done most of yours. It's writing code, deploying infrastructure, monitoring it, just day in, day out. Just rewind back to 2019. That's what traditional IT is. That's not going away. Still going to be here. Now, the next piece is AI solution engineering, and then machine learning solution engineering. I separate the two. Basically, it has to do with the model. If you're taking a model off the shelf, I don't care if you're going to Hugging Face or if you're going to OpenAI, Claude, whatever. You're using off the shelf models, whether you run it locally in your on prem or on a laptop in your space, whatever, and you're building your solution around that, then you're doing AI solution engineering. At least that's what I'm calling it. Building your agents, your MCP servers, all of that stuff. So, what do I see as the future of solution development? Well, we can get started with your traditional solution engineering. You have your coding, you have the infrastructure, and the operations. So, it's what you're doing today. You go write some code, you put together some Terraform, you build your CI/CD pipelines, you've got your testing, you deploy it, you've got your application performance monitoring solution, New Relic, Datadog, whatever, App Insights. So you've got all of that stuff in place. That's what we do. Oh, yeah, and security stuff. All right, so then we have AI solution engineering, where you're going to build your solution from existing pre-trained models. Yeah, whether it's Grok, OpenAI, Claude, or you go to Hugging Face and you're going to pull down a model and you're going to run it on-prem or in the cloud, whatever it is. You're not messing with that model. Most of your work is in context or prompt engineering. You're building tools and MCP servers. You're front-ending that model with your own code. So there's still the traditional IT engineering stuff in this solution. But the key feature is that model, you're not touching it. Agent services. So, in all the agent services is you've got some trigger that starts the prompt. That's all that is. So at the next level, we have ML solution engineering. So you're going to actually get into machine learning now. That means you're collecting data, you're doing curation, you're processing that data, all of those types. You're actually going to be creating custom models. That's, to me, the big differentiator between AI engineering and machine learning engineering. You may be taking an open weights model and fine-tuning it, that type of stuff, but the big piece is you're creating a new model. You're messing with that. So with machine learning engineering, you're also going to have AI engineering, because once you have that model all put together, you're going to have that front end stuff, prompting, uh, putting together tooling, MCP servers, things like that. And then you're going to have your traditional IT stuff, the website that front ends it, or maybe it's for IoT devices and they're sending stuff back. Whatever it is, you're still writing code at some point. So, kind of the things about these things. There's, for instance, your traditional solution engineering, it's familiar. There's a ton of room for growth here. And I'm sorry, we are nowhere close. People might think IT is boring, but there's so much stuff that we have yet to have touched with just writing code. Um, so many of these agent solutions that I've heard of, it's like, why didn't you just write? You could have done that with PowerShell. And what are you doing here? Because it's cooler using using the machine learning, dude. Come on, man. Stop messing with me. So, cool thing to this is there's a big existing talent pool. You know, all of these devs are sitting around. They know how to do this stuff. AI solution engineering, hyped. I mean, seriously. Uh, Everybody is talking about this stuff. It's frontier still, even now. I feel like I'm late to the party, and the truth is, I'm a late early adopter, really, which I'm used to being an early adopter. I don't know. Maybe I'm just old now and slowing down. Thing is, being an early adopter, high risk, maybe it's high reward. Who knows? I mean, that's part of the thing that makes it so funny is these guys are building these solutions thinking, oh yeah, cha-ching. These all of these AI, these videos on YouTube, these guys are, oh yeah, I've made an AI agency and I'm making millions. Uh-huh. Sure, Ty Lopez. Small talent pool. Despite all the hype, the number of people who legitimately are real AI engineers, and I'm playing around. I'm a script kiddie as far as AI engineering goes. There are some of the people who I'm listening to that are legit AI engineers. They know what they're doing, and I pay attention to what they're saying, and you should too. Machine learning, nobody's even really talking about this that much. Little bits, but I mean, you got to dig deep before you start to really gain awareness that there's this whole other world within AI. This is the early adopter, like early adopter research. This is, like I said, mad scientist type stuff that you're getting into. And again, the guys with YouTube channels where they've got all of their NVIDIA graphics cards heating their home, and they're building models and stuff. It's cool stuff. I mean, that's where I want to go. Not everybody's doing this. Very, very few people are there. And that's my point. What talent? I mean, you've got, I don't know how to measure it, but it's not a lot of people who are doing this stuff yet. So, good opportunity there. But from what I can tell, there's a pretty steep learning curve. There's a reason you don't see as much of this, and it's not that common. And yeah, sure, you can follow some videos and real quick throw together and train a model to do something, do your hello world. I have a feeling you're not going to get a job with that as your portfolio. You've got more work to do. I've got a lot of work to do over the next year or so. So, what's going to drive an organization to choose between these for building their solutions? Well, with traditional solution engineering, you have a known budget. I mean, yeah, projects get challenged constantly. There's always details that get missed. But by and large, there's a confidence interval that you can predict, and I can tell when I go into a project how successful we're going to be. And I expect other people have that. It's not a special talent; it's just experience. Oh yeah, I've been here before. I know how this goes. We know how to schedule it. You know roughly, again, you know what schedule means. We also know how to secure these things, mostly. God, till the next IT breach comes along, find out that somebody put a backdoor in your TCP/IP stack, and yeah, and we know how to operate these things. Yeah, so once you've got your solution deployed into the infrastructure, you've got your new relic agent on it, and you're watching stuff, and you know how to upgrade it and how to scale it and all those things. So you're good to go. No problem. Low risk. Again, so you know what the risks are when you get into it. And honestly, it's fairly low risk at this point. AI solution engineering, on the other hand, we're still learning everything. I mean, how do you deal with prompt injection attacks? How, um, the regulatory landscape. So Europe just passed this law. I've not even looked at it yet, but apparently it's going to be a major headache for everybody. The technology is rapidly evolving. So every 3 to 6 months, you've got to deal with, uh, new things. MCP servers uh, are wonderful, but it's a brand new technology. We're still figuring that stuff out. Potentially, it's high risk. So I work for healthcare. We're regulated a lot of different ways. We can't use AI. At least we can't use AI in the cloud. So, going to, Anthropic or OpenAI or Grok or any of the models that are hosted by somebody else, that's not going to work. We do have some projects where we run the model on prem, but we're still trying to figure that stuff out. How do you secure that? How there's just it's all questions, and it's very high risk. Um, for the solution engineering piece for machine learning, I don't even think it's on most organizations' radar. I don't know this for certain, but I'm just guessing the complexity, um, the need for hardware, or even if you're using cloud resources, going to Azure or AWS or Google Cloud, and renting the GPUs from them to train your model. I don't know. However, if your organization is brilliantly smart and you've got the talent on hand, this could be a major competitive advantage. I also kind of should say getting good at AI solution engineering could be a major competitive advantage for organizations, because, well, you use the technology better. By the same token, getting really good at just basic IT would be a competitive advantage. I would say one of the big reasons Walmart, um, through the 80s, was so dominant was they had some really good IT. They actually used the technology available at the time really well. The data warehouse, which it was incredible at the time, um, they stored every receipt in that data warehouse, and they data mined the out of it. Uh, they knew exactly where all of their customers were coming from. They knew how far they were driving to get to the store. They knew what they bought, when they bought it, how often they bought it, all of that type of stuff. And because they were so good, they mopped the floor with everybody. Um, it wasn't just it wasn't just one thing, but that was a major competitive advantage that they had, and they used it a lot of different ways. So, competitive advantage, machine learning. Potentially, by building your own models, it's a way to mitigate some of the risks with AI solution engineering. We're just using somebody else's model through the API. By building your own model on prem, one of the things that I understand that there's court cases with regard to copyright infringements and other details that are still working their way through court. So how does that affect you if you're using OpenAI to do your solution and court comes down and says, yeah, you can't do that no more? How does that affect you? So by going off and building your own model that avoids those things and it's specific to you, it may help you avoid dealing with some of that stuff. And like if you're a healthcare organization dealing with HIPAA, you don't want your patients' medical records being used in the training data for OpenAI's model. That would be bad. So what drives these different things? First thing is the budget. How much money do you have to spend? Because by and large, the cheapest thing still, despite what I said earlier of that AI is going to make the developers more productive and thus make solutions cheaper to deliver, we're not there quite yet, I don't think, because we're still figuring out as developers, how do you use this effectively? Because you don't want the AI just writing your code for you. There's practices and standards and how do we do this? I think that's still being sorted out. So your budget for traditional solution engineering is probably going to be the cheapest. AI, a little more expensive and is going to be specific to the problems. Machine learning, I think, is going to be much more expensive because the data and what you have to do and just the whole process, it's higher risk. There's thus more money involved. How long do you have to get to market? This is an interesting one. In some cases, the AI solution may actually let you get to market quicker. So you might want, hey, look, we can use the AI slop to at least get to the market with an MVP and then come behind it with a more full solution using traditional IT. If it's like, hey, look, it's worth taking the time to get this solution because it'll be so powerful by building our own model, then machine learning. So there. Your risk factors. Again, do you want this data being exposed to a third party who may or may not use that in their training for their model? So that's, also, so, prompt injection attacks. All of these different things are going to drive your solution, the selection of which way you go with building your solution. Then you got regulations. HIPAA right there makes AI and machine learning solutions more challenging because you have, as a healthcare provider, you have to comply with that stuff, at least unless you think going out of business is cool and being, I think you can actually serve prison for violating HIPAA, by the way. So, but there's other regulations, FAA, FCC, just there's so many regulations. And then also international. So many businesses, work internationally. So you've got to navigate EU laws, Chinese laws, Japanese laws, Indian laws. All of that stuff is all going to affect how you build your solution. Then at the end, probably this is the one, that budget and the value. That's going to drive the solution selection. All right. So, taking a really long time to get down to, so what? Who cares? What do I do? With regard to traditional solution engineering, you need to master your skills. You need to know your C# in and out, or whatever language it is you primarily use. You just need to know your tools really, really well and just be an ace at what you do. And that, okay, learn new roles. So, hey, I'm a programmer. I just take the user stories and I write my code and I submit my PR and, have my Oreo cookies. Become an SRE, become a UX engineer, learn compliance, learn all of these different laws that affect the solutions you're building. Still be a programmer. I'm still, at the end of the day, I don't call myself a programmer. I call myself a software developer. And it's because I do infrastructure, I do the security, I do the project management, I know the business, I know how budgeting and all that type of stuff affects what I do. So My point in all of this is pick up some other roles and learn to do them pretty well, just to be more versatile so that you're kind of the person who, you know, your manager or director, it's like, oh yeah, you know, send David over there to fix that problem. You know, David's your guy for this, whatever. Be that person. Next, start learning to use AI in your current role and the one you're learning, you know, but get really, really good at using AI as a helper. Just as a user, you're not building AI solutions yet. We're just talking, use it to do your job and make yourself more productive. That thing I was talking about before. Make yourself 10x more productive. Next, AI solution engineering. If you want to go this route, you're going to have to start learning an API for the AIs. You know, learn how to talk to OpenAI, learn to talk to Llama, learn to talk to Grok, and so on, so you can use it in your own code. Learn prompt and context engineering. This is, I think this part's really fun. I've had a blast learning this stuff. And then, you know, learn the AI tooling. I've started, I misspelled it. There's a Y in Jupyter Lab. But Jupyter Labs, or Jupyter Lab, N8N, just all of those type of tools, learn how to use them because, well, they're part of the landscape for what you're going to use to build your solution using AI. And learn to set up RAG. So learn how to take all of that document, all of the documents and stuff you have and code, learn how to feed it into a vector database, and then set up so that whatever AI you're using can access that vector database to answer your query. Learn to write an MCP server. I haven't done this yet, but it just seems reasonable that you would want to know how to do that, because when the project comes up that, hey, we need an MCP server written, you want to be the person that gets picked. Hey. So learn to use full agentic workflows. I've not really done this yet, but it makes sense. I've seen videos where people are doing that type of thing. It just makes sense. On machine learning, machine learning solution engineering front, I'm just starting on this part, full disclosure. What the output of the learning is, you should be able to know how to build a model. You should know how to fine-tune a model. There's a bunch of math. I'm not even talking about the curriculum. There's tons of videos that other people have produced that talk about what you should go study. But my point here is that when you're done with this, you should be able to build a solution where you either create the model from scratch, or you take an existing model, fine-tune it, and then use it as part of your solution. So you're just kind of going, you're going to demonstrate your AI engineering skills, and then you're going to back it up with your machine learning skills. That's how I see things. So this has been long and winding and rambled a little. My apologies, but these are my thoughts. If you made it that far, I'm trying to build this channel. I'm going to keep doing this regardless of whether you click like and subscribe, but I'd love it if you did. I'd love it if you jump into the conversation. I'd love to hear back from you. I'm excited about what's coming. I think it's going to be very cool for us. And I look forward to seeing what happens next. So I'll talk to you later, man.